A cross-section means if you were to slice, say, an orange. Look at the cross-section form when you cut a sphere in half. So of all the slices of an orange, I would always get the shape of a circle. Well, if I were to cut on the diameter, I would get what's called the great circle of the sphere. It's the largest circle formed at this cross-section. Surface area of a sphere is equal to 4 pi r squared. Copy down this problem. Go ahead and work it out in your calculator. When it says round to the nearest hundredths, you're doing 2 decimal places. Your eye needs to look at the third decimal place. If the third decimal place is 5 and above, you would give it a shove. 4 and below, let it go. Notice that our answer is in inches squared because it's an area answer. Copy down this example. On this example, they give us a diameter of 10, not the radius, so we need to cut that in half. We're rounding to the nearest hundredth, so that's 2 decimal places. Put your eye on the third decimal place. 5 and above gives it a shove, 4 and below lets it go. Volume of a sphere, 4/3 pi r cubed. Now this button on our calculator is above the x squared button. It's an x to the box, so you have to press a 3 on this one. Find the volume of the sphere to the nearest hundredths when your radius is 2. Copy this example down. Find the volume of the sphere when the diameter is 10. The circumference of a great circle of a sphere is 25 inches. Find the volume of the sphere. With this one being a circumference of 25, we need to find the radius. Circumference is equal to 2 pi r. Substitute into the 25 into your circumference. And then you want to solve for the radius. To get the radius by itself, you would divide both sides by 2 pi. Keeping this answer in your calculator, move it straight into the volume formula. You can hit second negative, which is the answer button, and it will recall that number for you. We're rounding to the nearest hundredths. So we need 2 decimal places. Put your eyeball on the third one. Our answer will be in inches cubed because it's a volume answer. Copy down these ratio relationships. We've actually seen these before. The ratio of any A to B is our scale factor. It's also the corresponding sides and the ratio of the perimeters. The ratio of any of the areas is A squared to B squared. The ratio of your volumes is A cubed to B cubed. Copy this down. We have a balloon with an initial radius of 5. We put more air into it and the radius becomes 10. Explain how the volume has changed as the radius has changed. There's a couple of different approaches to this one. You can actually calculate it and then compare your calculations, or we can go back to that ratio relationship. When it goes from 5 to 10, it has doubled. It has a ratio of 1 to 2. So anytime I'm comparing volumes means it's going to cube that amount. So it's going to be 8 times as much. And you can see in our numbers, this 523.6 is in this 4,188.8. This is 8 times as much as the other one. So you can back this up with calculations. But remember, this question said explain how the volume changes. So in this answer, you would need to say something about it being 8 times as much. A sphere has an initial volume of 400 cubic centimeters. The sphere is made bigger by making the radius 4 times as big. What's the new volume of the sphere? So again on this one, we're going to use the ratio relationship. I'm going to do this radius 4 times as big. So it's a 1 to 4 ratio. Well, when finding volume, it cubes that amount. So it's really looking at a 4 cubed, which is 64 more times the volume. So 64 times the 400 gives me my new volume. A sphere is inside of a cube-shaped box. To the nearest centimeter, which is the nearest whole number, what's the volume of the empty space in the box? On this picture, you need to try to figure out, well, what two shapes do I have? Now, we haven't talked about a cube, but you learned about it in elementary school. So we're going to do length times width times height. It's a cube, so they're all the same. They're all that 16. Now, what part of the 16 is also of the sphere? That would be our diameter. So the diameter of the sphere is 16. I need to find the volume of the sphere and the volume of the cube, and then subtract to give me this empty space. See if you can calculate what you think is the answer, and then check to see if you're correct.